Question number 3b, we have to state the discontinuity if they have any, where it exists, and then the domain, and then we need to find the limits at each of those discontinuities. Okay, so let's first factor. You should always factor it first. That determines if you have a hole, which is a removable discontinuity. The top is a difference of two squares, and it does give me a hole, a removable discontinuity. I need to figure out where that is existing. Okay, I have a removable discontinuity at x equaling -3. So that means, I know you may not realize this, but this actually graphs a linear function. It's actually going to graph this, like that. But at -3, it's going to have a hole. So this guy's domain is -infinity to -3, union -3 to infinity. The range, I'd have to figure out where the hole is actually existing. So I know the hole is at -3, but I don't know the y value. So you plug this into this equation, and that figures out whatever's left over. You just plug it into whatever's left over, and I get -6. So that means my range has a break at -6. Okay. So the limit, as you're doing this at this discontinuity, remember you do it from the right, you do it from the left, okay, so as I am coming from positive infinity to x equaling -3, do you see that this graph is going to this -6? I mean, that's where the hole is, but that's what it's going to, and I didn't put a negative. And you come over here, going to from -infinity to that -3, and where is that graph going to? Well, it is also going to -6. Now, when I plug -3 into the equation, I have a problem, and here is the problem. So you had, let's see, -3 minus 3 on the top part, and then you had -3 plus 3. So I'm going back to the original problem that I factored, and then -3 plus 3. So this is 0, and this is -6, and this is 0. So -6 times 0 gives me 0. And over 0. You can't have 0 on the bottom. That is an undefined entity. So these three things are not equaling the same thing. So the limit as x approaches -3 of f of x does not exist.